Okay, so I just wanted to make a overview of chapter 8, kind of so you can see the differences between arithmetic and geometric. That's what chapter 8 is split into. Okay, so we have arithmetic, and then we have geometric. All right. So with arithmetic sequences, those are the kind that we're going to be adding numbers in between to get to the next term. So what am I adding here? I'm adding 8. So 6 plus 8 is 14. 14 plus 8 is 22, etc. Okay, what about for geometric? That's where we're going to be multiplying. So if we have 10, 20, 40, 60, no, not 60, 80, etc. What am I doing? Well, I'm just multiplying by 2. 10 times 2 is 20, 20 times 2 is 40, 40 times 2 is 80, etc. So all you need to do is remember or have written down on your note card, if that's something you want to do, is that when we're finding the nth term of an arithmetic sequence, we can use the first term plus, because we're adding an arithmetic sequence, n minus 1 times d, which d is our common difference, okay? Or we can take our nth term can also be a sub m or some other term times n minus m times d. Now, really quick, what does all of this mean? These are just functions, okay? A1 is a function of an. I mean, a function of n and d that helps us find an. We put these inputs in, we get an output out. All right. So let's say we were told A1 equals 32, and the 71st term is A71 equals negative 458. Would we be able to find A sub 37? Well, A sub 37, okay, that's going to be based off of some other term, A sub m plus n minus m times d, right? I could use that, or I could use the A1 times n minus 1 times d. But either way, I'm going to need to know this d. When I'm just given two terms, I don't know d, all right? So let's go ahead and first find d. So in order to do that, we need to say, okay, I have the 71st term and I have the first term. I don't have anything in between. So let's take this a sub n equals a sub n plus n minus m times d. Let's plug in what we do have. So I have a sub 71 equals, okay, a sub 1 can be a sub n plus n is 71 minus m is 1 times d. Oh, I didn't put a sub 1 in there, but I do have a sub 1. That's 32, right? And I didn't put a sub 71 in there, but I do have that. That is negative 458. Oh, wow, that's nice. I have everything but d. So that means I can solve for d. This is going to go to 70. So negative 458 equals 32 plus 70 times d. So take 458, negative 458. Let's subtract 32 from both sides. I get negative 490 equals 70d. Divide by 70, and I get d equals negative 7. Okay, so now what do I do? Well, I have d, I'm looking for a sub 37, but I also have a sub 1. So I can use the equation a sub 1, or sorry, a sub n equals a sub 1 times plus n minus 1 times d. So a sub n is a sub 37 equals a sub 1 is 32 plus n minus 1 times d. What is my n? Well, n is that subscript right there. That's what that's called. So that's going to be a sub 37 equals 32 plus n is 37 minus 1 times d. What is d? Negative 7. So this is going to be negative 30, or sorry, this is going to be positive 36. 37 minus 1 is 36. So 36 times negative 7 plus 32. So a sub 37 is going to equal negative 220. Okay, so that's how you kind of use both of those. All right. Let's say we're given the first 4 terms, you have to ask to find the next terms. That way is easy because d, we can just calculate saying, oh, I'm just adding 8. And then we just plug it into this first equation. All right, but what about summations? All right. Summations are a little different. So if I'm asked to find the sum of the first 12 terms of a sequence, okay, I'm going to use, or the arithmetic sequence, I'm going to use this equation. So what this means is I'm going to take the first term and the last term that I'm adding, multiply that by n, and then divide by 2. Okay, so let's say I was given 3 plus 1 plus negative 1 plus negative. So what is this little plus plus plus? That means I'm going to keep adding up all the terms that are in between negative 1. Sorry, that should be a negative 1, not a 7. Negative 1 and negative 261. All right. But given that I don't have a d, I need to know a d. Do I need to know a, sorry, I do have a d. I can find a d, but I don't have an n. I don't know how many terms I'm adding up here, but I can find that out. So the d, we know this is, given this is an arithmetic sequence, or we can find out that it's an arithmetic sequence by noticing, oh, I'm subtracting 2 every time. Okay, so I'm going to keep subtracting 2. What does this mean? This means a sub n equals a sub 1 plus n minus 1 times negative 2, where a sub n is, sorry, let me get my pen back, negative 261, and a sub 1 is 3, right? What am I trying to find? What's my goal? I need to know how many terms we have. So negative 261 equals 3 plus, oh, I'm going to do one step here. I'm going to subtract 3 from both sides. So I actually have negative 264 equals negative 2 times n minus 1. I'm just going to go ahead and divide by negative 2. So I get 132 equals n minus 1. Let's add 1 to both sides. And I'm going to get 133 equals n. So now that I've found n, what good is that? Well, s sub n is now s sub 133. And that's going to equal n. Oh, yeah, that's why I needed to find n. I need to find the n in the equation times a sub 1, which is 3, plus a sub n, which is negative 261, all over 2. So after doing the work in the algebra there, we'll get 17,157 negative. All right. Now, what about if we have funky sum? Looks like this. What does this mean? This is just like if I have the sum of I equals 1 to 3 of x, or of, not of x, that wouldn't mean anything, of I. That's going to mean I'm going to start at I equals 1, and then I'm going to add, the next I would be I equals 2, and then I'm going to add I equals 3. Then I'm going to stop at 3 because that's where my upper limit went. Okay, my lower limit was 1, my upper limit was 3. So this means I'm going to go from j equals 1 to 92, and I'm going to plug it into here. So that's going to equal 4 times j plus 3. Then I'm going to add the next j, which is going to be 2, plugged into there, etc. So you can see how this would kind of be tedious if we had to do that all by hand, right? Because we're going to keep going until 4 times 92 plus 3. But what we can do is we can do the first few terms so we get an idea of what's going on. This is going to be 7 plus 11 plus 15 plus all the way to 371. So now we have a first term and a last term. Our d equals 4. We know this finding n on these ones is easier. N there is 92. I'm adding up from 1 to 92. That's n terms is 92. So then I just do s sub 92. Oh, what is happening? Sorry, my pen is freaking out. S sub 92 equals, okay, n, 92, times the first term, which is 7, plus that last term of 371 divided by 2. You should get this. Okay. So that's the general idea behind arithmetic sequences or series. All you need to know or remember are these two equations, the summation equation, and how each works, what d is, what n m means, okay? And knowing that the subscript relates to the term that you're talking about within the sequence. So similarly, let's look at geometric sequences. Geometric sequences, the same things apply, okay? So we would have, instead, we have a different type of equation because we are multiplying, okay? We have a sub n equals a1 times r to the n minus 1. Okay. Could we find the 13th term of this right here? Well, that would be a sub 13 equals a1, which is 10. R is what we're multiplying by. Again, this n right here is the same as this n. So we go 13 minus 1. Okay, which if we multiplied that all out, we would get 40,960. Okay, what about another equation for a sub n? A sub n we can also think of as a sub n to the r times n minus n minus m. Okay, so let's say you have a sub 1 equals 19 over 81. A sub 6 equals 57. Can we find a sub 10? It goes through the same process that we went through before. Okay, a sub n, okay, let's use a sub n as a sub 6 equals a sub 1 times r to the, okay, n is hold on, pause. I think I messed up this equation. No, I didn't. Okay. A sub m, n is 6. Oops. 6 minus m is 1. Okay, I don't have r, right? But that's what I can find because that's the only thing I don't know right now. So a sub 6 is 57 equals 19 over 81 times r to the 5th power. Okay, so we need to multiply by 81 over 19, multiply by 81 over 19. All right, and then we would take the 5th root and we would get r equals 3. Okay, so now we have r, but we're trying to find a sub 10. So a sub 10 is going to equal a sub 1 times r to the 10 minus 1. Where did I get that from? I got that from this equation. So this is going to equal 19 over 81 times 3 to the 9. When I solve that, I get 4,617. All right. So we can see that again, I'm just using the fact that we've got these two equations and a geometric sequence to kind of puzzle these together, okay? Think logically through these puzzles. So again, S sub n, that means the sum of the first n terms. For a geometric sequence series, that's going to be a sub 1 times 1 minus r to the n over 1 minus r. So again, I just have a formula I use. So 3 to the 1, if I have this, 3 plus, I'm going to leave a gap there for a reason, 3 to the 1/2 plus 3 times 1/2 squared. I said 3 to the 1/2 over here. I just meant 3 times 1/2 plus 3 times 1/2 to the 6th. How many terms am I adding up here? Well, I'm 6 to the 5th, to the 4th, to the 3rd, to the 2nd, to the 1st, to the 0th. So I'm actually starting at 0, going up to 6. So that means I have 7 terms. So I'm finding the sum of the first 7 terms of the geometric series. So use this formula. S sub 7 is going to equal A1, which is 3 times 1/2 to the 0. 1/2 to the 0 is just 1. 3, A1 is 3. 1 minus, what is R? In this case, it's kind of obvious what R is, right? It's, okay, I'm multiplying by 1/2 every time. So minus 1/2 over, sorry, 1 minus 1/2 to the n, which is 7, over 1 minus 1/2. So simplifying this, we'll get 3 times 1 minus 1 over 2 to the 7th over 1 minus 1/2 is just 1/2. Which we can continue simplifying that down. Okay, and we'll get 381 over 64 as our final answer. What about if it looks like this? I equals 1 to the 8th. So the sum from I equals 1 to 8 of -3 to the I, -3 to the 1, plus negative. So what I'm doing here is I'm just kind of writing out the first few terms. And then, oh, okay, that's going to go from -3 to the 8th, right? So what is my first term? Well, that's -3 to the 1, so that's going to be -3. What is my R? I'm multiplying by -3 every time, so that's also -3. So S sub 8, how many terms am I multiplying by? I'm multiplying by 8 terms. I mean, I'm adding 8 terms, sorry. A1 is -3 times 1 over -3 to the 8th. And I keep just saying little things wrong. 1 minus -3 to the 8th over 1 minus -3. I'm sorry. Solving that, simplifying that is going to get us this answer. So I'm not simplifying it for you merely so you can have practice and so this recording is not super long, okay? So the only difference now between geometric and arithmetic sequences is the infinite sum. If I have something that looks like this, so instead of from 1 to 8, I'm going from 1 to infinity. If I have something like this, well, first thing to note is that if R, the absolute value of R is in between 0 and 1, then I am going to have a sum. If it's greater than 1, my sum is infinite. That means I can't calculate it. It's just going to keep growing and growing and growing. But take a look at this. This is my box. This is the number I start with. This is my A sub 1. Let's say I multiply by a quarter. Okay, my next term is going to be this. So I'm going to add 1 plus this quarter. Then I'm going to add, okay, I'm going to multiply by another quarter and another quarter and another quarter. Get the idea. Okay, I'm going to start getting so small that those little bits are going to start being negligible. So I'm going to actually add up to a sum of some kind. So this one that I gave you, okay, is infinite. So that doesn't really have a solution. But let's say I have one-third to the I. Well, my sum is going to be A1 over 1 minus R. So A1 here equals 1/3. And then I do 1 minus 1/3. You can see that that's going to give me a pretty decent number. I'll get 1/3 over 2/3. Which is going to give me 1/2. Okay. So there's the differences between arithmetic and geometric series sequences.